Hi, welcome to the 16th Let's Think Secondary Science lesson entitled Will It Sink? The last four of the lessons that we're using with the students in here are really quite difficult. And so you need to be very, very careful about how you set up the activity, how much you want to quantify the results, because it depends on your class, your relationship with them and how they'll respond to it. We can approach the more difficult aspects of compound variables and equilibria qualitatively, and it might be that that's what some students do, and you can follow up these activities later, taking them through the work cards at a later stage, or even in year 9, depending on your students. But again, the message with all of these lessons is think carefully, plan carefully with your peers, run through them and decide what is best for your students. Can you create, as I saw in the lesson in Shropshire the other day, can you create a narrative that flows through the lesson? So you raise a problem, the students investigate, and they come back to the problem with new language and new understanding, and you can then take them even further using the work cards. So in this activity there are 3 work cards you can use at the end, depending on your class, depending on your time. You might do any of them, but there are more than enough resources. And again, as I've mentioned several times, think about the PowerPoints. Are you going to just put a blank slide up and explain to the students? Are you going to give them out? All of this needs careful planning because we don't want it to get in the way of the thinking and challenging the students. So Will It Sinks, there is a couple of work cards you can use. A simple one of the girl and the elephant, because we're exploring pressure, the compound variable pressure. Or the snowshoe one and skis, who will sink further, just to get the students to talk, just to open them up, just to get them to air their ideas about how the 2 variables are interacting. And then your students actually carry out their own little activity and share their results. As you've seen from the equipment, we're carrying out standard activity exploring how far some little platforms sink into the sand. There are 2 ways you can do this one. If you use the round dowel, it's much harder to quantify, but the students will get a rough idea that thin ones sink further. All right? Or you can get some square dowel and they could actually, if you want to, work out the surface area and quantify it and quantify it. So what you do is you would need to explain the setup to the students and let them carry out their own activity, exploring how area and the mass that you put on affects how far it sinks in the sand. I mean, this is a really good activity to find out if your students can carry out a controlled practical to investigate and tease out the difference between the 2 variables. If they don't get it, the idea that we can have different diameters, different areas and different masses will give you the same resulting pressure, a work card will follow that up later. In this activity, you're probably going to need 4 different areas of dowel to give the students enough variation to generate the results for discussion. We've chosen to focus on mass and area because these variables are concrete enough for the pupils to handle individually, and the outcome pressure, which you need to decide when you share it with the students, probably later, as some might say it, but it might need to be introduced during the feedback before you move on to the work cards. They can probably grasp the outcome variable as a product. You know, the area and the mass are giving pressure, and that results in how far it sinks. So they can probably handle that. The next step, which some students will get, is for them to grasp how the outcome variable is a result of a ratio that can be derived in a range of ways if we change the variables independently. So we can have the same pressure by just changing by changing both of the variables. So we could have a small area with a lighter weight will give you the same pressure as a big area with a heavier weight. So really, we want the students to understand that we're combining 2 variables to create a 3rd related variable. So we've got mass and volume relate to density, we've got voltage and resistance linked to current, and here mass and area relating to pressure. So, as I've said, the students will carry out their own experiment. And you don't need to worry because the work cards will lead them through, and actually exposure to the problem and working through it will enable them to join in with the thinking and will be sufficient to moving their thinking on. As the students carry out their own activity, they will get a real handle for how two input variables, two independent variables such as area and mass, result in a third compound variable. And it's important to let them explore and see how these interact together, because it's the tip of the iceberg in terms of moving into the more harder science that they'll do in Key Stage 4. So one of the later lessons that we look at looks at density, you know, how mass and volume interact together, and then looking at relative density. So it's important to give them the time here to concretely explore what's going on with the variables and articulating that we've got a new compound variable here. And actually the next step is to start to quantify that so they can see how the variables will interact together and give you a ratio so we can calculate how different areas and different combination of masses will all sink to the same depth. Once the students have got their results, or you feel they're ready to talk, we'll move into the part of the lesson that requires the most sensitive handling, because they will have a lot of different ways of articulating the relationship. So if I increase the mass and increase the area, it'll sink to the same depth as it did when it was a smaller area and smaller mass. So you'll need to give them a chance to do lots of pair talk share, lots of repeating, lots of scribing on the board what they say as you start to approach and formalise the relationship. And even when you introduce the term compound variable, when you introduce the term pressure, because the students will need to have a go at inventing their own language to describe what's going here, because we've got a new variable that comes as a combination of two variables. I mean, the work card does help here in that this table here will really get them, for many classes, will be the end of the activity, because there's a constant link between the area and the mass that because all these rods sink to the same depth. So this will take a lot, will be enough discussion for many of them, and will really challenge them to think about variables in a completely different way. So in a sense, lesson 16 onwards sees us moving to really pushing their understanding of how variables interact and combine together. And then there's also, which I'll talk about in a moment, the 3 work cards that you can use in whatever way you feel. You know, that we've been more than generous with the resources for you to use and explore how you can develop this thinking with your children that goes beyond these individual lessons, because there are only 10 lessons in Year 8. So you do need to think carefully about how to use them and how to follow up the ideas, building upon them with the work cards that we've provided. For many students, it's this work card that will enable the penny to drop, because you can then bring home the idea of weight and area ratio. And if it's the same, they'll sink to the same depth. And then they'll start to use the word pressure, and that the fact to understand this is a compound variable that has come from 2 variables interacting. So you can ask questions like, what will happen to the pressure if you increase the weight? What will happen to the pressure if you reduce the area but keep the weight the same? How much they quantify it isn't as important as starting to play around with how the variables interact together and the possible outcomes from that. You know, and that really underpins a lot of high level thinking in science. And the 2 other work cards are just there for you to further reinforce the idea, or even introduce a new compound variable, which in this example is concentration. So we're thinking about what the orange juice will taste like if you use different amounts of water and orange squash. Can you get 2 juices to taste the same if you vary the amounts of water and orange squash? So because it's a table and the children are filling in data, it might be quite an interesting activity for them to take home, or to do at a later date.